I apologize for that. I accidentally hit the wrong button on my computer. My screen was getting dark from inactivity, and I went to just touch the keyboard to keep it alive, and I actually pressed it too hard, which causes the thing to stop. So this is 16 part 2, or 16B, slide 16, sample puzzle about the lemon, my cool little lemon friend with the sunglasses. So what I was saying a moment ago was that Aristotle's criterion not only applies to the shape of the lemon, but also to the size of it, because you can see the size and you can verify it with your sense of touch, right? So remember this. This is a metaphysical criterion for differentiating between objective and subjective. Brilliant. 2,300 years ago, Aristotle, ancient Greece, sitting around in his armchair, pondering the nature of reality and the criteria that differentiate different categories of reality, subjective versus objective, right? Pardon me. So he didn't speak about intersubjective. Intersubjective is a subdivision of subjective. It's a kind of subjective, like red apples and yellow apples are different kinds of apples. So subjective is the general category, and intersubjective or non-intersubjective would be subcategories of subjective, right? So because all human beings can experience the sweetness of honey, let's just say, but with only one sense organ as opposed to two. We can't hear the sweetness of honey. We can't see the sweetness of honey. We really can't smell the sweetness of honey. We can't touch it, but we can taste it. But we all human beings taste it that way. But certain other species will react to it negatively. It doesn't taste sweet to them. So obviously, the human tongue plays a role in the experience of sweetness, in which case it's not merely subjective, but intersubjective. If it was subjective but not intersubjective, then it might be sweet to me and sour to you, right? But all human beings taste the sweetness of honey, which is because it has sugar in it. Sucrose, glucose, whatever, fructose. I'm not sure which tose it is, but you understand. It's like the citric acid in a lemon. All right, so the last one on the list is whether or not the color yellow on the lemon is subjective, objective, or intersubjective. Now, I want to pause for a moment and ask you to think about that. Remember, you can pause the video so that I don't waste too much time here. Okay, I'm back, right? And if you're not ready, then pause it. But here I am, I'm back. No, it's not objective. And no, it's not subjective. Yes, I know about color blindness. And the thing about color blindness is that people with different rods and cones, not cones, a koan, K-O-A-N, is a Zen puzzle. Cones, like ice cream cones, C-O-N-E, are receptors in your eyes. So people who are colorblind, they lack a certain level of sophistication in their receptors to be able to differentiate between, let's just say, blue and green, right? So things that are blue and green come in as the same. And the way that you could test that is you could like make a little circle with a happy face and with all these little tiny little circle bubbles inside the circle that are blue and green. And let's say like all the background circle bubbles inside the big circle bubble are blue, but like eyes and nose and like mouth bubbles are green. So if you can't differentiate between blue and green, all you see is one big circle of the same color. If you can differentiate between blue and green, then you see that there are green eyes and a nose and a mouth in the drawing. right? And the difference is because you have these differentiating rods and cones, right? So that's physics, right? So, but let's just rule all those differences out and imagine that all of us have the same rods and cones, right? And so we all, when we look at the lemon, there's my friend, the lemon. Oh, it doesn't really, the light is not, oh, there he is. See the lemon over there with the sunglasses on? When you look at a lemon and you see that it's yellow, let's assume that it's fully yellow and not like an unripe lemon that might be a little green or something like that. Only beings that have human eyes see it as yellow. And the problem of color blindness, it's almost as if people who are colorblind are almost like members of another species in terms of having different kinds of receptors in their eyes. So certain kinds of insects and other kinds of mammals and reptiles and amphibians and whatnot all have different kinds of eyes and receptors in their eyes, and we can analyze them and figure out what they are and what electromagnetic frequencies they can detect, because that's what light is. Light is an electromagnetic radiation, like waves coming from the sun. Rays are like waves of radiation coming from the sun, right? A wavelength. You've got this kind of wavelength and this kind of wavelength, and you've got this kind of wavelength, very slow and low, woo, right? High frequency, low frequency, right? Different kinds of wavelengths. And those wavelengths stimulate the rods and cones in your eyes. And those are like almost like fish nets that have big holes in them and little holes in them, and like the little wavelengths can get in and the big wavelengths can't. And so like our eyes are receptors that pick up certain frequencies, and so are objects. So like the surface of the lemon, you know that everything is made out of atoms. And there's more space in an atom than there is matter. One way of thinking about the matter and the space in an atom is to think of Swiss cheese. So the holes in Swiss cheese are the space, and the cheese is the matter, right? So, but when it comes to atoms, there's a whole lot more holes than there is cheese, right? So like you take a solid object like a rock or a table or something like that, and it's like something like way more than 99% of it is holes, and less than 1% of it is cheese. But like the way that the atoms connect, the electron rings, like the outer ring of an atom, when this electron connects with that one and they bond together, the atoms stick together and the electron rings are kind of circling around each other, right? That's what kind of binds them together, like hydrogen, hydrogen, and oxygen, right? Those three, two hydrogens and one oxygen, create one molecule of water, and all the water together, it behaves a certain way, right? Most of it is empty space. Most of it is non-cheese, and matter is the cheese, but it's like there's more holes than there is cheese, right? So take the surface of a lemon and think of it as a kind of net where the electrons are the cheese and the space between them is like the non-cheese in a slice of Swiss cheese, right? And so like the surface of an atom has all these gaps in it, like a net, right? And then the wavelengths of light, when they come in, right? There's this kind of frequency and this kind of frequency, really slow, and the small ones and whatnot. And then really, so like the different ones, some of them go right in through the spaces and get absorbed into the lemon because of the size and shape of the wavelength and the size and space of the cheese, the cheese versus the empty spaces in the cheese, the matter versus the energy or empty space. And what it turns out to be is that, the wavelengths of light are all these different wavelengths. Each one of them causes a different color when it bounces off the eye. But the ones that go into a wave of light contains like all the colors of the rainbow blended together. We need something to separate them, like when you see a rainbow in the sky, or you use a prism to separate them, right? But you don't even see light until it bounces off of something, right? Or when you see a rainbow, I'll explain that later. But really what happens with light, like with the lemon, is that all the wavelengths that don't cause yellow when they touch the eyes go right through the spaces on the surface of the lemon because of its atomic structure. They go right through the net. But the ones that cause yellow, they don't fit in the net. They don't get absorbed by the lemon. They bounce off the lemon and then stimulate your eyes. So the lemon is a kind of yellow electromagnetic wavelength repeller. The surface of the lemon repels yellow wavelengths, which bounce off of it so that when you look at it, those wavelengths are touching your eyes and causing yellow sensations in your brain. Right? The lemon is actually everything except yellow. It absorbs. It's friendly. It's like blue friendly, green friendly, red friendly, violet friendly, purple friendly. It's red friendly. It's friendly. It absorbs all the colors of the rainbow except yellow. It's everything but yellow. It repels yellow. Yellow bounces off of it and touches your eye. Right? So when you look at the lemon and you think the lemon is yellow, it's because the lemon is repelling the yellow. It's non-yellow, the lemon. Not only that, but those wavelengths don't have colors. They stimulate rods and cones in your eyes, which go through the visual cortex, and your brain creates the sensation of yellow, which it projects onto the source of that signal, so that when you're looking at the lemon, you're experiencing yellow. But the lemon is a yellow repeller. It's not even a yellow repeller. It's an electromagnetic wavelength repeller of the frequency of wavelengths that when that wavelength touches your eye, it stimulates your brain to create the sensation of yellow, right? So yellow is actually in the brain. This is not philosophy. This is physics, the physics of perception. Now, is color in the object or in the subject? Or is it intersubjective? If all human beings experience yellow looking at the lemon, then at least initially it seems like yellow is not objective, it's intersubjective. Pause to think about that for a moment. Colors don't exist in the world, if that analysis is correct. Colors exist in the mind only. The world has no color. I don't know how we could be racists if there's no color in the world. Well, that's a comforting thought. It's really worth thinking about. There's no color in the world. Similarly, there's a famous philosophical puzzle question, which even was once featured in a funny Geico commercial. If a tree falls in the forest and there's nobody there to hear it, does it make a sound? Think about the analysis that I just gave about color with eyes, color bouncing off of objects, and that there's no color in the world. Light is just vibrations and wavelengths. Sound does not exist in the world. All there are is vibrations, stimulating, vibrating eardrums, which creates sound sensations in the mind. So, chicken and egg type question. If a tree falls in the forest and there's no one there to hear it, does it make a sound? No. Ears plus vibrations make sounds. Similarly, if the leaves on a tree in the forest are green, but there's nobody there to see them, are they really green? Answer is no. Colors require light vibrations, electromagnetic radiation bouncing off of objects, touching eyes, connected to visual cortexes and brains. The world is without color and sound. That's pretty freaky. Therefore, color and sound are intersubjective. Interesting metaphysics that you never thought about. It only gets worse. Welcome to the crazy world. That's just scientific thinking. That's not even philosophy yet, quite.